Hello everyone, I welcome to all of you to official channel of Novelty Tutors. In our last lecture, we have studied to calculate distance between any two points given on a straight line and also to calculate slope of a line. Let's begin our new lecture with a new topic, that is angle between two lines. Say two lines are given, namely L1 and L2. Line L1 makes angle alpha 1 with respect to x-axis and line L2 makes angle alpha 2 with respect to x-axis in anti-clockwise direction. So, angle between two lines, let us denote this angle as theta and this angle as phi. If I consider intersection points of two lines as O, intersection point of line 1 on x-axis as A, intersection point of line 2 on x-axis as B, considering triangle OAB, we can write it as this angle as theta, this angle as alpha 1 and exterior angle as alpha 2. As we already know, exterior angle is equal to sum of two opposite interior angles, that is theta plus alpha 1. So I can write theta as equals to alpha 2 minus alpha 1. So theta is what? Angle between two lines. To calculate this, we have to use some trigonometric formulas. Let us say tan of अल्फा माइनस बीटा. आपने ट्रिग्नोमेट्रिक फंक्शंस में ये टॉपिक कवर किया हुआ है. tan ऑफ अल्फा माइनस बीटा इज इक्वल टू tan ऑफ अल्फा माइनस tan ऑफ बीटा अपॉन 1 प्लस tan अल्फा इंटू tan ऑफ बीटा. So from line 1, slope of line 1, let us write it as m1 equals to tan of alpha 1. Slope of line 2 is equal to tan of alpha 2. So I write from equation 1, theta is equal to alpha 2 minus alpha 1. Taking tan on both sides, taking tan function on both sides, I get tan of theta equals to tan of alpha 2 minus alpha 1. Now, from the trigonometric formula tan of alpha minus beta, I can write tan of alpha minus beta as tan of alpha minus tan of beta upon 1 plus tan alpha into tan of beta. So, from equation 2, I can write tan of theta equals to tan of alpha 2 minus alpha 1, that can be written as tan of alpha 2 minus tan of alpha 1 upon 1 plus tan alpha 2 into tan of alpha 1. From slope formula, I can write tan alpha 1 equal to m1, tan alpha 2 equals to m2. Replacing tan alpha 2 with m2, tan alpha 1 by m1 upon 1 plus m1 m2. I can write it as tan of theta. Now theta is equal to tan inverse m2 minus m1 upon 1 plus m1 m2. This is angle between two lines. Now angle between two lines can also be written as phi, right? We can also write phi equals to 180 minus theta using angle sum property. Total angle is 180 degree. So I can write theta plus phi equals to 180 degree. So using this equation, I get phi is equal to 180 minus theta. So I can write phi is also equal to 180 minus replacing value of theta tan inverse m2 minus m1 upon 1 plus m1 m2. So angle between two lines gives me two results, one for theta and one for phi. So I can conclude that if theta is acute, then tan of theta will be positive and phi say obtuse, since phi equals to 180 minus theta. That can, if theta is acute, then 180 minus theta will be obtuse. That can be written as then tan of phi will be negative. So angle between two lines can be written as theta equals to tan inverse m2 minus m1 upon 1 plus m1 m2, and also I can write it as equals to phi, that is 180 upon 1 minus theta. So what I conclude from here in a very simple way, that tan of angle between two lines, it can be positive or it can be negative. So in general, angle between lines is written as tan theta equals to mod of m1 minus m2 upon 1 plus m1 m2. As per question perspective, you can write it as positive or negative. Let us do one example. Say angle between two lines is pi by 4 and slope of line 1 is 1 by 2. Find slope of line 2. From the given formula, I can write it as angle theta equals to pi by 4, slope of line 1 m1 equals to 1 by 2, and slope of line 2 m2 I have to calculate. So I can write it as tan of pi by 4 equals to m1 mod of m1, that is 1 by 2, minus m2 upon 1 plus m2 into 1 by 2. Solving tan pi by 4 is 1 equals to, taking LCM of 1 by 2 minus m2, I can write this as 1 minus 2 m2 upon 2 plus m2 whole mod, denominator 2 to cancel. As we know, mod gives two values, that is one is positive and another is negative. First let us consider positive value plus 1 minus 2 m2 upon 2 plus m2, and second case let us consider negative value, that is 1 minus 2 m2 upon 2 plus m2. Solving equations from positive, 1 equals to 1 plus 1 minus 2 m2 upon 2 plus m2, cross multiplication 2 plus m2 is equals to 1 minus 2 m2, rearranging the terms 2 minus 1 minus 2 m2 minus m2, I get m2 is equal to minus 1 by 3. From second equation, taking negative value, 1 minus 1 minus 2 m2 upon 2 plus m2, rearranging, cross multiplying 2 plus m2 minus 1 plus 2 m2, I get 3 is equal to m2. So angle which the line 2, a slope of the line 2 is either minus 1 by 3 or 3. How is this possible? Let us draw it on graph. For line 1, angle is 1 by 2. Let us represent here. It is line 1. I am just drawing a general line, not exactly. Line 1, angle 1 by slope 1 by 2. For line 2, I can draw it as either for positive value, its theta must be, slope of line is acute. So I can write it as in this way. Line 2 alpha 2, that is equal to tan inverse 3. Or also I can draw it here as line 2 with tan inverse minus 1 by 3. Next topic, we will cover collinearity of 3 points. Say 3 points are given, and to prove that the 3 points are collinear, how we can prove? Say a line 1 is given, say 3 points P, Q and R are given on the line such that coordinates of point P, H, K, Q, x1, y1, R, x2, y2. So, for 3 points to be collinear, necessary condition is slope of any 2 points, say slope of line joining by any 2 points, first say PQ must be equals to slope of line QR. Or I can also write a third condition, slope of line between any 2 points, say PR must be also equal. So how we can prove this? To calculate slope of line, you can watch lecture number 1 as we have already discussed. Slope of line PQ can be written as y1 minus k upon x1 minus h, and slope of line QR I can write as y2 minus y1 upon x2 minus x1. Necessary condition, taking first 2 at a time, slope of line PQ must be equal to slope of line QR. I can write, comparing the 2 equations, say 1 and equation number 2, I can write y1 minus k upon x1 minus h equals to y2 minus y1 upon x2 minus x1. So rearranging and cross multiplying the terms, I can write y1 minus k equals to x2 minus into x2 minus x1 equals to y2 minus y1 into x1 minus h. This is my general condition for 3 points to prove that they are collinear. और ये क्वेश्चन आपकी एनसीईआरटी में भी गिवन है, एग्जाम्पल नंबर 4, और ये क्वेश्चन काफी बार एग्जाम्स में पूछा जा चुका है कि what is the general condition, yeah, how to prove that 3 points on a line are collinear. Let us take another example. Say 3 points are given. First is, say A, x comma minus 1. Second point B, that is 2 comma 1. Third point C, that is 4 comma 5. It's given that points are collinear. Find value of x. Two methods. Either use the condition slope of points AB must be equals to slope of point joining BC, or directly using the obtained result. So मैं कैसे कर रहा हूँ, slope of line AB equals to slope of line BC. AB means 1 slope, 1 plus 1, 2 minus x, 5 minus 1, 4 minus 2. 2 upon 2 minus x equals to 4 upon 2. Rearranging and cross multiplying, I get 2 minus x equals to 1. So x equals to 2 minus 1, that is equal to 1. This is my required answer. Yes, thank you everyone for watching our videos. Please do like, share and subscribe our channel. We will be waiting for your valuable feedback in our comment section. Thank you.